Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. In this video, I'm going to look at an inequality question that was on the 2013 higher level paper. It was question 2a on paper 1. So as you can see, I have a quadratic here, and the question asks, find the set of all real values of x for which the quadratic 2x squared plus x minus 15 is greater than or equal to 0. Okay, it's still a quadratic, so what I would do is I would solve that like I would any other quadratic. We will then deal with the inequality sign, and I'll show you how that slightly changes the question from something that would look like this, which is just solving a quadratic, to the inequality version, which has, instead of an equals to sign, a greater than or equals to sign. Okay, so just like we would any other quadratic, I am going to solve this one. So I have 2x squared plus x minus 15, and for the purpose of solving it, I'm going to have equals to 0. You have two choices here, as you have with any quadratic where you have more than two, but two I'm going to look at is I could factorize it and solve, or I'm going to do the minus b formula. And just in this example here for practice, I'm going to do both. So to factorize it, we look at the factors of 2x squared, and for that it's 2x and x. It's a prime number, so it's easy to factorize. I then want the factors of minus 15 and 5 and 3. 5x and 3x will do there. So what am I doing? Well, I can see that I need a plus 1 in the middle. So I have 5x here, I have 6x here, and I know that if I plus the 6x minus the 5x, I'm going to get my plus 1x in the middle. So I need a minus 5x and a plus 6x. Okay, so that's one way to come up with these factorizing. And then you split the brackets and you let each factor equal 0. And you solve. And you solve by subtracting 3 from either side, or bringing over the number. Divide both sides by 2, and x in this case is equal to 5 over 2, or 2.5. Okay, so that's one way people factorize. I might show you another way people factorize. Okay, so I'm going to redo this bit. This is another option for this bit. Okay, so again, I start off with my quadratic, and I look at the guide number of it's a by c. Okay, any quadratic is ax squared plus bx plus c. So if I go a by c, I get minus 30 as a guide number. It's a very useful way of doing it when you have a number in front of x. So the factors of minus 30, and again, I need these to give me a plus 1. So it could be something like 15 by 2, or minus 15 by plus 2. Note that I took the sign with the minus 30 to make it easier for myself. It could be 30 and 1, it could be 10 and 3, or it could be 6 and 5. Okay, it is going to be 6 and 5 in this case. I need a plus 1, so this is the right pair that gives me the plus 1 that's in front of the x in my quadratic. So here. Okay, plus 6 minus 5 gives me that plus 1 that's here. So an extra line when you choose this method, you rewrite the plus x here as plus 6x minus 5x. Okay, where did I get that? I took the two values from here, look, and I've just rewritten plus x as plus 6x minus 5x. So I haven't changed it, I've just rewritten it in a different way. And I still have minus 15 being equal to 0. Okay, if you remember grouping from junior cert, so take out the 2x, it's common between these two here, and I'm left with an x plus 3. Take out what's common here, well the minus is common, the 5 is common, and I'm left with x. It has to be a plus here, so that minus by plus here gives me that minus equals 0. And then the last line of grouping is to group together your factors. So the 2 on the outside, 2x minus 5 goes into one bracket, x plus 3 goes into the other bracket. Okay, and you can see now that I have the exact same line as I have up here. So when I solve that, I am also going to get x is equal to 2.5, x is equal to minus 3. Okay, now obviously in your exam you're not going to do all of these methods, you're just going to do one. And then or you could use the minus b formula, and you can use the minus b formula for any quadratic at all on your course. So just like I said up here, we have 2x squared plus x minus 15 being equal to 0. This is an ax squared plus bx plus c is equal to 0. Whatever written there in orange is what's called the general form of any quadratic. So in it, you can see that your a value is 2. So in other words, the coefficient of x squared term we call a, that's 2 in this one. The coefficient of the x terms we call b, that's 1 in this one. When there's no number in front of x, it's 1, it's not 0. And my c is 15. And from your log tables, you'll see that the minus b formula is minus b plus or minus the square root of b squared minus 4ac all over 2a. When you do that formula enough, you will learn it off just like I reamed it off there. Okay, so my a is equal to 2, my b is equal to 1, my c is equal to minus 15. Okay, so minus b, so minus 1 plus or minus the square root of b squared, 1 squared minus 4. Always safer to put your b in a bracket, 4ac all over 2a. Okay, where did I get that? There's my b squared minus 4, 4 is in the formula, ac all over 2a, where a was 2. So I just filled in the numbers above. Okay, so into my calculator I'm going to put 1 squared minus 4 times 15 times 2. So I'm just going to put that into my calculator. Times 2 times minus 15. I got 11 all over 4. Okay. Now at this stage, we deal with this plus and minus that was here all the way down. Okay. So if you look above here, you'll see that for any quadratic I get two answers. I got 2.5 and minus 3. So where does the two answers come from in the minus b formula? Well, it comes from me splitting that sign as such. So I get minus 1 plus root 11 over 4 will give me one answer. And the second answer will come from the minus, so that I get minus 1 minus root 11 over 4 to give me the second answer. So when you're putting them into the calculator, hit that fraction button first. Oh, and I made a mistake. I don't know if anybody noticed. I had root 11 instead of 11. So I'll just correct that back up again. Should have 11. Fair play to anybody who spotted it before I did. So minus 1 plus 11 all over 4 gives me 5 over 2. And minus 1 minus 11 is minus 12 over 4. And I get minus 3. Okay, and not surprisingly, the two answers I got here are the exact same two answers I got up here. Okay, so choose any one of those three methods to solve your quadratic. Okay, and these values are what's called your critical values. Okay, so I would call x is equal to 2.5 and x is equal to minus 3 my critical values. Okay, so you're not finished. And you're not finished because we used an equals to sign to solve it, and we haven't yet dealt with the inequality sign. Okay, so if I just do a rough graph here, okay, in fact, let me center it a bit better. Okay. Right, now if I was to draw a rough sketch of that quadratic, I would see that it's a smiley face. It's a smiley face because the 2x squared term is positive. So it's always a smiley face when that's positive. If that was minus 2x squared, it would be a sad face, which is a frown. But this is positive. The other thing I know is its solutions or its roots. So you can see that it crosses the x-axis at minus 3 and 2.5. And you know that from solving the quadratic. Okay, so your quadratic roughly goes as such. Okay, let me just line up my points. So that's your minus 3, that's your 2.5. And that's my rough graph. Okay, and it's just a sketch. I don't know how far it comes down here on the y-axis. I just know that it crosses the x-axis at minus 3 from here. It crosses the x-axis at 2.5 here. Okay, so now what did the question ask? The question asked, when was this graph greater than 0? When was the graph greater than 0? Okay, I would argue that anywhere up here is when any graph is greater than 0. Okay, this here is the 0 line. Okay, it's when y is 0, when your output is 0. Okay, in the same way, I would argue that anywhere down here under that line, as such, is less than 0. Okay, and if you think about it, this is where all the y values are less than 0. Okay, these are all the positive values, or when they're greater than 0. Okay, so the question, when is that graph greater than 0? So in other words, when is that graph up in this area of the graph? Well, can you see that it is over here and this line goes on forever, and over here and this line goes on forever? So the way you answer it is when your x values is less than or equal to minus 3, which is out here, and when x is greater than or equal to 2.5. So that's your answer to that question. Okay, if the question had been when is 2x squared plus x minus 15 less than or equal to 0, then it would have been when the graph is in this green highlighted section here, and my answer would have been when x lies between minus 3 and 2.5. Okay, that's not what you were asked. It's what's up here in black. This is your answer. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice? In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.